All right, we're ready to finish up with Module 2, Lesson 1. I'm going to try to get it in one video, so we'll see if we can do that, not make it too long. So we're going to continue on with what we did before, and like I said, copies language just becomes more and more and more important as you continue with the different methods. So the 2 still represents the number of intervals per rectangle. So 2 intervals here, 2 intervals here. And to know how many to shade, this is where your copies language comes in. 3 copies, remember it's the number that are shaded, the top number, of 1/2. So this is half of a rectangle, this is half of a rectangle, this is half of a rectangle, and this is half of a rectangle. And so you can see why 3 are shaded, because this is 3 halves, or 3 copies of 1/2. 1, 2, 3. So again, even without knowing how to change a fraction into a mixed number, I can see this is 1 and 1/2. When I'm going to learn that later on in this chapter, that 3 halves turns into 1 whole and a half. So this is 2 copies of 1/3. So that means I need to break the rectangle into 3 equal pieces, and I need to shade in 2 copies. So 1/3, 1/3, 1/3, because 3/3 makes a whole, and I need to shade 2 copies. And remember, 3 is the number of intervals. This one we didn't have to use the second triangle because we could shade our 2 in the first one. So this one tells me 4 intervals. So we cut it in half again, and this one is 7 copies of 1/4. And so I can see I don't have enough. I only have 4 copies of 1/4 there, because 4/4 makes a whole. So the next triangle or rectangle is also going to have to be included. So 1 copy of 1/4, 2 copies of 1/4, 3 copies, 4 copies, 5 copies, 6 copies, 7 copies of 1/4. So I can see 7/4 is pretty close to 2 wholes. Here's 1 whole, here's 2 wholes. And if I were to write it as a mixed number without even knowing how to do it, I could say it's 1 whole and then 3 copies of 1/4, which is 3/4. So 7/4 equals 1 and 3/4. Okay, let's do the next one, and then you guys can take on the next one. So this one needs next 2, I guess. 5 intervals. So 1, 2, 3, 4, 5, and this is 3 copies of 1/5. So there's our 3/5. 3 copies of 1/5. Okay, next 2 are yours. Go ahead and turn off the video. Try those 2 on your own, and then turn it back on, and we'll check your answers. Okay, number 4 is 7 copies of 1/8. So that means I need to break this into 8 intervals. So cut in half, cut in half, cut in half, cut it in half, cut each half in half, and cut each fourth in half. So we can see an 1/8 is half of a 4th. So 1, 2, 3, 4, 5, 6, 7, 8. And this is 7 copies of 1/8, 2 copies, 3 copies, 4 copies, 5 copies, 6 copies, 7 copies. Because remember, each one of these is 1/8. So 7 copies of 1/8 is shading in 7 of those 1/8 figures. For the next one, we have 3 intervals. And so there's only 3, so there's no way to make 5 copies of 1/3. So that means the second one needs to be shaded, or needs to be divided into 3 intervals as well. And I had a student ask me last semester, and it was a good question. I would have never even thought to go over it. He said, would you ever divide this into 3 and this into 4, for instance? Never. Because this tells me 3 intervals, that means 3 intervals in both rectangles. So now I need 5 copies of 1/3. And remember, each of these is a third. This is a third of the whole, this is a third, 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 because 3/3 make a whole, and these are 2 wholes. So 5 copies of 1/3, 3 copies, 4 copies, 5 copies, and I can see as a mixed number that would be 1 whole and then 2 out of 3. So without even knowing how to do the long division, I can tell that 5/3 as a mixed number would be 1 and 2/3. Just by looking at the picture, because each rectangle represents a whole. 1 and 2 out of 3 colored in. So that was fun, right? It's a lot more fun when it's not 1 in the denominator or in the numerator. And this is another one where you really got to use the copies language. Students have such a hard time with this one until they learn you need to use copies. And then it makes it so easy. So this says divide the picture into 2 groups or 2 intervals. In this one, it's kind of more appropriately to say groups. So here's a group. So this is half of the picture, and this is half of the picture. And this says I want 3 copies of 1/2. And like I said, you look at it this way and it's so easy. But the students that try to do it without using the copies language struggle. So 1 copy of 1/2 would be 6. Another copy of 1/2 would be 6 more. The third copy of 1/2, 6 more. So it's just 3 of these, because this is 1/2 and this is 1/2. So 1 copy of 1/2, 1 copy of 1/2, 1 copy of 1/2. So there's 3 copies of 1/2. So easy when you think of it like that. Copies is just the greatest word. I don't know who invented it, but I love it. So this next one says 2 copies of 1/3. Well, first I have to figure out what 1/3 is by dividing it into 3 equal groups. I can't go this way. That divides it into 4 groups, but I can go this way. Here's a third, here's a third, there's a third. So each of these is a third of the whole picture, and I need 2 copies over here. So 4 triangles for 1 copy, 4 more triangles for 2 copies. So there are 2 copies of 1/3, or 2/3 of the triangles in that picture. Fun and easy, right? Copies language is awesome. So let's do this last one together, and then you can do the 2 on the next page. So this is 5 copies of 1/4. So I know I need to break the picture into 4 equal parts, since we're talking about 1/4. So I can't do rows. There's only 3 rows, but I can do columns. See how it makes 4 equal groups? So this is 1/4, this is 1/4, this is 1/4, and this is 1/4. So I need 5 copies of 1/4. 1/4 is 3 triangles. So there's 1 copy of 1/4. There's 2 copies of 1/4. There's 3 copies of 1/4. There's 4 copies of 1/4. And here's the 5th copy of 1/4. So 1/4 consists of 3 triangles, 1, 2, 3, 4, 5 copies of 1/4. And that would have been so hard to do without that language, but so dang easy with it. Super fun. So let's have you guys do the 2 on the next page. Make sure you got a good grip of this. So you're going to do 1 with 5/4 and 1 with 4/5. And remember, this means there has to be 4 groups. So if you need to do the division by hand, go ahead and do the division. Count the rectangles, divide it by 4 so that you know how many will be in each group. Okay? And then come back when you have your pictures drawn and we'll check them. Okay, so this is 5 copies of 1/4. But I don't know what 1/4 is. There's no rows or columns or anything here, so I'm going to have to add 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 divided by 4 groups means there's going to be 4 per group. So here's 1/4. Here's 1/4. Here's 1/4. And the last 4 make up the last 4th. And this says 5 copies of 1/4. Well, 1/4 is 4 triangles. So 1, 2, 3, 4. There's 1 copy of 1/4. There's 2 copies of 1/4. 3 copies of 1/4. 4 copies of 1/4. And 5 copies of 1/4. There we have it, because 1/4 consists of 4 triangles and we need 5 copies. I hope everybody did okay on that one. And last but not least, 4 copies of 1/5 means I need to divide the group or the picture into 5 groups, and that will be easily done. 1, 2, 3, 4, 5, because there's 5 columns. Now I can't do it this way. That would only make 3 groups. I need 5 groups, so 1, 2, 3, 4, 5. So each of these is a 5th. And I need 4 copies of 1/5. So there's 1 copy of 1/5. There's 2 copies of 1/5. 3 copies of 1/5. And 4 copies of 1/5. Because 1/5 is equal to 3 triangles. Awesome! Fun stuff, huh? Okay, so moving on. We're going to talk about simplifying fractions. So I think most of you in your math life have heard of simplifying fractions. That's where you find a common factor, something that divides into both, in order to put the fraction in simplest form. So first we read the picture, and remember how to write a fraction. It's how many are shaded over how many make a whole. So 2 are shaded out of 4 make a whole. And I can see that 2, because they're both even, I always pick 2, can go into both of these, and that simplifies the fraction to 2 divided by 2 is 1, 4 divided by 2 is 2. And I can see this is equal to 1/2, because if I divided it into 2 rectangles, 1 out of the 2 rectangles is shaded. So it's easy to see the equivalent fraction from the picture. Here we have 4 that are shaded out of 5, 6, 7, 8, 9, 10. So once again, both even, so I can divide both of them by 2. and I get 2/5, then I look at 2/5 and make sure it can't be simplified any further. Nothing common between 2 and 5 except 1. So if we were to divide this into 5 rectangles instead of 10, 2 of those rectangles would be shaded. There's the 2 that are shaded, and here's the 3 that are not. So you can easily see why 4/10 is equal to 2/5, because when we divide it into 5 separate rectangles, 2 of the rectangles are shaded. Next we have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10, 11, 12, 13, 14, 15. So my go-to when I'm simplifying fractions, and is if they're not even is 2, 4, 6, 8, 10. That means 2 doesn't go into them, so the next number I try is 3. Does 3 go into 9? Yes. Does 3 go into 15? Yes. So 2 is always my first one. If they're not even, then I try 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. And I can see that 3 and 5 don't have anything in common besides 1. Okay, let's do 2 more and then I'll let you guys try the last 4. So this is 3/4. 3/4. What number goes into 3 and 4? 1. That's it. So that means the fraction does not simplify. It's just equal to 3/4. It's already in simplified form. Okay, one more and then I'll let you guys practice. So next we have 1, 2, 3, 4 out of 6. Here we are back to 2 even numbers. So because they're both even, I divide by 2. And I can see 4, 6 simplifies to 2/3. If I was to divide this into 3 big triangles instead of 6, you can see that 2 of the 3 triangles are indeed shaded. So anytime you get your answer, it's really easy to check. That was 4 out of 6. This is now 2 out of 3. So you can see they are equivalent. This is just called the simplified version. Okay, next 4 are yours. So go ahead and turn off the video, practice on those, see how you do with your simplifying, and then come back and we'll check your work. Okay, this first one is 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 out of 9 it looks like. Did I count that right? 1, 2, 3, 4, 5 shaded out of 5, 6, 7, 8, 9. Does everybody agree? Nothing goes into both 5 and 9 except for 1, so that just stays itself. And next we have 3 out of 6. So one of the numbers is even, but the others isn't, so that means we can't use 2. So our second guess is always 3. Does 3 go into 3? Yes. Does 3 go into 6? Yes. So divide both of these by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And is that 1/2 of the picture? Yes, it is. If you divide it into 2 equal rectangles, you can see that one of the 2 rectangles is shaded. So we can verify that our answer is correct. And next we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 out of 10. Both even. So we kick in with 2. 6 divided by 2 is 3. 10 divided by 2 is 5. 3 and 5 cannot be simplified further. The only thing common is 1. So there's my answer. And last but not least, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 out of 9. 6 is even, but 9's not, so we can't pick 2. So plan B, pick 3. Does 3 go into 6? Yes. Does 3 go into 9? Yes. And 6 divided by 3 is 2. 9 divided by 3 is 3. 2/3 cannot be simplified further since only 1 goes into each. So that is our practice with simplifying fractions. And from here on out, for the rest of your math life, every single answer on every single quiz, test, homework must be simplified. And the directions won't always tell you because you're supposed to know that. So the rest of your math life, every fraction you write should be in simplified form unless told otherwise. Okay, I guess we got one more here to do. 1, 2, 3, 4, 5, 6, 7, 8 in the numerator. 9, 10, 11, 12, 13, 14. And I see they're both even. That tells me to pick 2, pick 2. 8 divided by 2 is 4. 14 divided by 2 is 7. Okay, so it looks like more of the same thing. Determine the fraction of the whole represented by the region. Find all fractions of a simpler form. That means simpler numerator and denominator. So we start out with 2 over 4. Both even. So that means I divide by 2 and that gives me 1/2, and I can see that this is indeed 1 out of 2 boxes shaded. Okay, this one is 4 out of 8. Four out of 8. And both even, so we can divide by 2. 4 divided by 2 is 2. 8 divided by 2 is 4. So is this also 2 out of 4 boxes? 1, 2, 3, 4. Yes, 2 out of 4 boxes shaded, but 2/4 isn't simplified. And if I could pick the #1 mistake on the final exam, that would be it. Students simplify and then they don't check to make sure their simplified fraction is simplified. These are still both even. That means they can be simplified again. So divide by 2, divide by 2, then we should have a box with 1/2 in it. 1 shaded out of 2 make a whole. So 2 make a whole, 1 of the rectangles is shaded. So that is the simplest form. Now this is simplified, but it's not the simplest form. So we circle the fraction that is in simplest form. Okay, I'll let you guys do number 3. So go ahead and shut off the video and see if you can find 3 different versions of the fraction given. Okay. Okay, so the first version looks like 1, 2, 3, 4, 5, 6, 7, 8 out of 9, 10, 11, 12. 8 out of 12. And then because they're both even, we can turn that into 4 out of 6. So let's see, can we make 4 out of 6 boxes shaded? There's 1 box shaded, 2 boxes shaded, 3 boxes shaded, 4 boxes shaded, out of a total of 6 boxes. So yep, that shows we're correct. If 4 out of 6 matches that picture, we're correct. But it's not simplified again. So we divide them both by 2 because they're both even. That's how we know it can still be simplified. They're both even and we get 2 out of 3. And we can go over here and say 1, 2, 3, 4. There's 1. There's 2. So 2 out of 3 of the rectangles are shaded. So I can see that all 3 of those fractions are equivalent. 8/12 is equivalent to 4/6, which is equivalent to 2/3. So they're all 3 equal to each other, but 2/3 is the one in simplest form. So that was fun. Okay, it looks like we have a couple more of these, and then we move on to, I think, the word problems. So we're getting close here. For each of the shaded regions, determine the fraction of the whole represented by the shaded. Find all the fractions of simpler form. Circle the one in simplest. Oh, so this is exactly the same thing. Just continued, I guess. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 9 out of 12. So I see that 9 is not even, which tells me I can't pick 2 for simplifying. So then I try 3. Does 3 go into both of these? Yes, it does. 9 divided by 3 is 3. 12 divided by 3 is 4. Nothing else will go into 3 and 4 except for 1, so that's my simplest form. And I can see if I divided this into 4, 1 box, 2 box, 3 box, and 4 box, that it is equivalent to 3 boxes shaded out of a total of 4. So I can see that these two are equivalent. Okay, one more. So this fraction is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 6 out of 18. And they want 4 fractions. So when I see that there's 4 different fractions, that tells me 6 and 18 can be simplified 2 different ways. 3 different ways, actually. Using 2, using 3, and using 6. So first let's use 2. So because they're both even, we can use 2. 6 divided by 2 is 3. 18, oh dear, I don't know why I wrote 8. 18 divided by 2 is 9. So this should also be 3/9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So sure enough, that is 3 out of 9 boxes shaded. But what you should notice is 3/9 is not simplified. They're not even, I'll give you that, but we always have to try 3 next. And 3 goes into both of those. 3 divided by 3, 9 divided by 3 makes it 1/3. So you can see this is indeed 1/3. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 2/3, and 3/3. And one of those 3 is shaded. So you're probably thinking, okay, I think we all agree that's the one most simplified, right? But you're probably thinking, whoa, wait a minute. We're done. Why is there a 4th box? Well, what if we would have started with 3 instead of 2? Or what if we would have started with 6? So we started with 2, both even. We started with 3, but what if we would have started this one with 6 or started with 3? So 6/18. What if we would have started with 3 instead of did 3 as the second step? That tells us that 2, 6 is also equal to all of those. Isn't that crazy? And then you would divide both of these by 2 and see it's 1/3. So you can see how they're all connected. They're all equal to 1/3. 6 times 3 is 18. 3 times 3 is 9. 1 times 3 is 3. 2 times 3 is 6. They all have the common ratio, multiply by 3 to get to the denominator, so we can tell they're equivalent. So 2 out of 6 would be 1, 2 shaded out of 3, 4, 5, and 6. So 2 out of 6 are shaded. So all of those are equivalent, but only 1/3 is the most simplified or completely simplified answer. Okay, so let's go ahead and do these last 3 pages. I think we'll just have a little longer video here at the end rather than make a new one. I think YouTube lets me do up to an hour and a half, but that's really too long for students. So we'll try to get done in the next 2 minutes so this isn't too long for you. So this is a common theme in both chapter 2 and chapter 3. What do we do with 2 fractions that have the same numerator? What do we do with 2 fractions that have the same denominator and we're trying to decide which one's larger? And what do we do if the fractions don't have the same numerator or denominator? How can we tell which one's larger? So for this one, we're going to draw pictures just to show what it looks like, and then you can make your own conclusions. So 5/8 is one of them. 1, 2, 3, 4, 5. And they don't let you draw pictures on the test because in order to draw a picture to see which fraction's the largest, your boxes have to be exactly the same size, and each square has to be exactly the same size. And most people cannot do that. So the directions we tell students before you take the quiz or test is make sure you don't use drawing pictures as your method to decide which one's larger. Because unless you are a perfect computer, you can't do that. And then 5 out of 16. So we can easily tell that 5/8 is larger than 5/16. And that's only because these are computer drawn, and you can see that this one is bigger than that one. Like I said, it would be really hard on a test to draw the exact same situation, but let's see if we can come up with a strategy so we wouldn't have to draw a picture. So if a pizza is cut into 8 pieces and you get 5 of them, those pieces are going to be a lot bigger than if a pizza is cut into 16 pieces and you only get 5 of them. So that's how I remember which one's larger is I think of a pizza cut into 8 slices, cut into 16, I get 5 either way. Which one are you going to get more pizza from? 5 out of 8. Or you can think of it like this. Which number's closer to 1? 4/8 is a half. This is over a half. 8/16 is a half. This is under a half. So there's a lot of different ways that you can look at it, but the rule is when the numerators are the same, and this is the exact opposite of what you were taught about denominators, so it's really a hard one for students to remember. That's why I say rely on the pizza. So when the numerators are the same, the smallest denominator is the largest fraction. And that's because you're closer to 1. So whichever fraction's closer to 1, that's your largest fraction. And 8 out of 8 is 1. 16 out of 16 is 1. So you can see this one is closer. So when the numerators are the same, the smallest, oh, I forgot to say denominator. I'm like going the smallest what? So the smallest denominator, which means bottom, is the largest fraction. So I know I see 5/8 and I see 5/16. These are the same. This is the smallest denominator, therefore it's the largest fraction. So it eats the big one. Numerator's the same, smallest denominator's the largest fraction. Or just look at it and say which one's closer to 1. 5/8 is closer to a whole pizza than 5 out of 16 pieces. Okay, so when the numerators are the same, the smallest denominator is the largest fraction. And students will tell me, what if I forget that rule? Well, in situation 3, I'm going to show you how you can use the same method on every problem, and then you don't even have to remember this rule. I will tell you, until I taught this class, I did not even memorize that rule. I just automatically made a common denominator and went from there. But there's a lot of these questions on the tests, and chapter 2 test, chapter 3 test, and the final. Like they'll have 3 numbers, 1/6, 1/3, and 1/2. And they ask you to put them in order from largest to smallest. Well, 1 out of 6 pieces, 1 out of 3 pieces, or 1 out of 2. This means you get half the pizza. That's the biggest one. And then they make you put in the greater than symbol. 1/3, 1 out of 3. This pizza only has 3 pieces and you get 1 of those. So that's the next biggest. And 1/6 is the smallest. So it eats the big one. This says 1/2 is greater than 1/3, which is greater than 1/6. So that's the kind of problems they have on your test and on your final exam, where you have 3 of them and you have to put them in the proper order. And sometimes they'll have it set up like this, and you have to put the numbers in. So you have to say, oh, which one's the largest? Oh, 1/2's the largest, so it eats the big one. And which one's in the middle? 1/3. And then which one's the smallest? 1/6. So sometimes they'll do that. So the very largest one has to be on the right when it's like this, because this says 1/6 is less than 1/3, which is less than 1/2. These are greater than signs, so it eats the biggest one, so the biggest one has to be on the left. So on this one, the largest one's on the right, this one, the largest one on the left, and they do both scenarios on your tests. So be prepared for that. Just always remember, it eats the biggest one. Eats the biggest one, and the middle number obviously has to be in the middle. So that's how you would arrange it. So the largest, or excuse me, when all the numerators are the same, the smallest denominator is the largest fraction. So the smallest denominator is the largest fraction. And that was true here, and it was also true here. Okay, when the denominators are the same, piece of cake. So first we have 7/16, 1, 2, 3, 4, 5, 6, 7. And then we have 11/16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. And so we can easily see with these machine drawn rectangles that 11/16 is larger than 7/16. And that's kind of why I don't like the rule above, because then it gets students mixed up on this one. So when the denominators are the same, the largest numerator is the largest fraction. Again, you can say which one's closer to 1. I get 11 out of 16 pieces of pizza. On this one, I only get 7 out of 16. So 11/16 is larger than 7/16 because it's closer to 1 whole pizza. So it's just the opposite of this. The large numerator is the largest fraction. So when the denominators are the same, the largest numerator, largest fraction. But when the numerators are the same, the smallest denominator is the largest fraction. See why I said that's confusing? Because most students know this one coming out of high school, and then when I introduce that one, they're like, oh, I'm so confused. So I say, don't even use that first one. This next method I'm going to show you works for all of them. So all you have to remember is this scenario. Largest numerator, largest fraction whenever the denominators are the same. And so the last one, we don't have the same numerators and we don't have the same denominators. And we can't use a picture on the test. We're not allowed to do that. I'm just going to show you so you can see. So we have 7/16. 1, 2, 3, 4, 5, 6, 7. And we have 3/4. So because the pictures are machine drawn, we can tell that 3/4 is larger. But you can't use that method on the test. So what we do instead is we find a common denominator and we use method 2 that we learned on the last page to pick. So common denominator, 16 is the smallest we could have. So I asked myself, does 4 turn into 16? Yes. So I can multiply 3/4 or 4 by 4 to turn it into 16. But whatever I do to the denominator, I have to do to the numerator. So now I'm comparing 7/16 and 12/16. Now I can easily see, using the method from the last problem, when the denominators are the same, the largest numerator is the largest fraction, because I almost have a whole pizza, 12 out of 16 pieces. Here I have less than a half. 8/16 is a half, and I have less. So then to answer the question, I can say that 7/16 is smaller than 3/4, because 3/4 turned into 12/16. So that's what they have you do on your test. They have you make them into the common denominator, and then they have you pick which one's largest. So 7/16 is smaller than 12/16, which is really 3/4. So 3/4 is the big one, and it eats the big one. And that's a pretty big problem in the next 2 chapters and the final exam. Right there. So that's a good one. Okay, we're almost to 45 minutes, so this is going to be a long one. We just got 6 more problems to do. And it's practicing what we just did on the last one. So when we're finding a common denominator, we always look at the largest denominator first. 6. Can I turn 3 into 6? Oh yeah, I can. Multiply it by 2, but whatever I do to the denominator, I have to do to the numerator. So that means 2/3 is really 4/6, and then boom, 4 out of 6 pieces is more than 2 out of 6, so I can tell that 2/3 is the largest. So then I do the same thing over here. 3/4, 9/12. I look at the largest denominator and say, can I make them both 12? Yep, 4 goes into 12. So I multiply by 3, multiply by 3, because 4 times 3 is 12, and this turns us into 9/12. Oh, well, look at that. Those two are equal. Oh, love, love, love the next one. All my work is done for me. The next two, I guess. 9/10 is more than 6/10. 5/12 is more than 2/12. Okay, these last two are yours. So we haven't had one like this, so I'm just going to explain it before you turn off the video. If 12 doesn't work, then you start doing multiples of 12. 12 doesn't work because 10 doesn't go into it. 12 times 2 is 24. Nope, 10 doesn't go into that. 12 times 3 is 36, or you're just adding 12. Nope, 10 doesn't go into that. 12 times 4 is add 12, 48. Add 12, 60. Oh, finally, I found a common denominator. So 12 goes into 60, and I know 10 goes into any number that ends in 0. So you're going to make both of these into 60. Okay? So go ahead and turn and do the same process here. 12 times 1, 12 times 2, 12 times 3, till you find a number 8 goes into. So you're going to have to change both denominators on the next two problems. And you will probably see this 4 times on your next test, 4 times on the next test, 4 times on the final exam. So this page is big, and the problems are usually like these too. So these would be good ones to highlight to tell yourself to study. I'll just highlight the stars to show they're on the test. Okay, so turn off your videos, work those two, and then come back to me and we'll check them. And then we'll be done with this video. Okay, so we just said that 60 is the number that both of these fractions go into. So I need to change them both to 60. So I know to turn this into 60, I have to multiply numerator and denominator by 6. So this turns into 36/60ths. For this one, to turn it into 60, 1, 2, 3, 4, 5, I can see I have to multiply by 5. So this one turns into 30/60ths. Now that I have them with the same denominator, now I can say, oh, 36 is the largest. So what does that mean? 6/10 is the largest fraction. And some of the problems on your test and quiz lead you through this. They say make them have a common denominator. Some of them will just say which one's larger. So you have to do the work on your paper without the prompting of Alex. You have to know to make them have the same denominator so you can pick the largest numerator. And using our list from 12 here, 8 doesn't go into 12. 12 times 2 is 24. Does 8 go into 24? Yes, it does. So I'm going to do the multiplication here just to make it easier. 8 goes into 24 3 times. 12 goes into 24 twice. So my two fractions are going to be 9. 3 times 3 is 9 over 24. And this one's going to be 14 over 24. So I can now see with a common denominator, 14/24 is the largest, which means 7/12 is the largest because we eat the big one. So always keep them in the same order. Always keep 3/8 on the left, 7/12 on the right, so you don't mess up your sign. Okay, that was a long video, but we are done with Module 2, Lesson 1. So I'll see you back on the next lesson.